Hi everyone. Today I will go over an example to show how to calculate the value function of Markov decision process recursively. So for Markov decision process, it's like stochastic control process in discrete time that solve an optimization problem in robotics, control, or economics. So the core concept of MDPS is to give you a policy that optimize the cumulative reward function instead of just the immediate reward function. So that is, if I want to go 10 steps from now on, what action should I take to maximize my reward in 10 steps? So as shown here, here are the two main functions of solving a Markov decision process. That is the value function of the state, Vt, and also the policy, so which is the u at state x to maximize such a value function. So let's just go through the example really quickly because it's kind of long. So for example, this is a 1 by 5 grid, so which label is A, B, C, D, E. And the reward is 10 for if you go go to A, and it's 1 if you go to E, otherwise it's 0. And to make the problem simpler, we'll just assume it's a deterministic process. So that is the P of like the state will be 1. So that is if you go left, it's always go left. You'll never go to right by chance. So we know the action is either left or right. Okay, so let's get started. So for example, if I want to know if I'm starting from D, should I go to left to get the 10 rewards in 3 steps, or should I go to the right to get the 1 reward in 1 step? Which one is greater? Which one is better? So actually this just depends on the gamma. So as we can see in our value function, there's the gamma, which is the discount ratio. Discount ratio is a constant number between 0 and 1. So if it's high, then it means we lose less if we take more steps. But if it's low, we know, okay, we lose a lot if we take one more step to go to the target. So that's the case. So now let's just solve the value function of our A, B, C, D, E to see if actually the action of D depends on gamma. Okay, so we always start from weight 0. So weight 0 should be the minimum of the reward of all the states. So keep that in mind. So that will equal to 10 because the reward of A is 10, and for B, C, D is all 0, and for E is 1. This is the V0. And then for V1, because A and E are the terminals, so we'll just stay there. So it's always 1 and then 0, 10 and 1. For B, so we have two choices, either go left or go right. And we know it's definitely better to go left because it's a reward. So our value function of that is to go left. So it's gamma times 10, which is the immediate reward. And plus the V0A. V0A is also 10, so it's gamma 10 plus 10 is 20 gamma. And similar for D, we know it's 2 gamma because the reward is 1 if we go right. And for C, we know either we go left or go right. Our immediate reward and V0 will always be 0, so it's just 0. So this is V1. And for V2, it's the same. So for A, B, D, E, because there's nothing changed. But for C, because V1 of B and D are not 0 anymore, so we need to calculate. So it's gamma times, so if we go left, we'll get 0 plus 20 sigma, and if we go right, we'll be 0 plus 2 sigma. So definitely like 20 sigma is better. So it's gamma times 20 sigma, which is 20 sigma squared. Okay, so let's do V3. So V3 is really interesting because if we calculate that, we know like A and E will be the same. But for B, we know if we go left, we'll So it's like a maximum of, if we go left, it's 10 plus 10, which is 20. If we go right, it's 20 sigma squared. So if we know, because like sigma is between 0 and 1, so it's always better to just go left. So this will still give us 20 sigma. And for C, it's the same. It's 20 sigma squared. So A, B, C, D, E. But for D, there's no space here, so just do it here. So it's 3D. It's kind of interesting. So it should be maximum gamma times max of, if we go left, it's 20 sigma squared. If we go right, it's 1 plus 1, which is 2. So how should I choose? So that is, if 20 sigma squared greater than 2, so sigma greater than square root of 0.1, then we should go left. So if sigma less than square root of 0.1, we should go right. So therefore, we showed that the choice of point D does depends on the magnitude of sigma. So hopefully through this video, you'll get a better understanding of how to solve or how to calculate the value function step by step in different like iterations. So yeah, thank you for listening.